Welcome, students. I am Aurora, the artificial intelligence system on Spacegate Station. In this episode, you will be reviewing some of the major concepts in basic coding, including algorithms, how flowcharts are used, the application of conditional statements, and the part that event handlers play. Please stand by for transfer to Spacegate Station.
I am sorry, Engineer Ross. I do not know what the trouble is. I have confirmed the transmission signal from the new Mars Rover, and I've also confirmed its location at the Bradbury landing site.
I don't know either, Specialist Barber. I just ran another diagnostic on the rover's hardware and everything is operating flawlessly. The rover is working fine until it gets to the geological surveying activities.
Huh. Well, it looks to me like it's not a hardware problem.
I agree. There must be a software issue. Probably a bug.
Processing. A bug is an insect distinguished by having mouthparts that are modified for piercing and sucking. A bug can also be a concealed miniature microphone used to monitor or record someone's conversations, or an individual that is annoying or bothersome. I am confused. I do not see how any of these definitions could be applied to the present problem with the Mars Rover.
No, Aurora. Engineer Ross was using the term bug as it relates to the Mars Rover's computer program.
Processing. In computer terminology, a bug is the term used to refer to errors in the source code of any software. When software does not work as expected, computer programmers study the code to determine why any errors occurred. This process is known as debugging and can be traced back to Admiral Grace Hopper, who worked at Harvard University in the 1940s. When one of her colleagues found a moth impeding the operation of one of the university's computers, she told them they were debugging the system. The term debugging was eventually accepted in the programming community to relate to the process of managing computer problems.
Thanks, Aurora. I didn't know that. Well, Specialist Barber, what do you think I should do? I'm an engineer, not a programmer. I only deal with the hardware.
Well, our IT specialist, Captain Caldwell, is presently in Lab 2. He's working on some new software to improve the performance of our station's directional thrusters. He could probably help you.
That's a great idea. I'm going to head over there now. Will you keep an eye on the telemetry data of the rover for me? And if anything happens, let me know.
Absolutely. I'll even keep both eyes on it.
Thank you.
Specialist Barber, I am confused. Why would you place your human ophthalmological system on a glass monitor? This would make it difficult to observe the data that is being represented as you would be in such close proximity to the screen.
No, Aurora, it's another idiom. It means to watch someone or something very closely to be informed of possible trouble.
Interesting. I will record this idiom for future use.
That's a good idea. Now, if you'll excuse me, I'm very busy. Please do not bug me while I finish the entries for this week.
Specialist Barber, I have no intention of secretly recording you while you work.
That's not what I meant, Aurora.
I do not have a physical presence, Specialist Barber, so I cannot see how you would be concerned I would be able to physically assault you by biting.
That is so not what I meant, Aurora.
You understand, Specialist Barber, that as an artificial intelligence, I am unable to access the chemical programming that resides within the human brain.
Aurora, you know what I meant, and you're doing it now.
My bad.
That should do it, Aurora. Let me know if the guidance system is now able to compile the new code.
Yes, Captain Caldwell. I estimate it will take 14 minutes and 31 seconds to confirm if the station's directional thruster operating system is processing the machine language properly.
Hey, Engineer Ross.
Hey, Captain Caldwell. I was wondering if you could help me. with a problem I'm having with the Mars Rover.
Sure, I just finished up a small project that I've been working on. What seems to be the problem?
I was asked to check out the latest Mars Rover to make sure that it was performing all of its designated tasks. However, there seems to be an issue when it goes to perform one of its geological survey activities at the designated waypoint.
Which task?
The problem occurs when it encounters loose Martian regolith.
Regolith is the name given to the weathered volcanic rock that appears as sandy soil on Mars. There is also a thin surface layer of very small dust particles. The soil has a reddish color because it contains a lot of iron oxides or rust. In contrast to Earth, the soil on Mars is the same everywhere because global dust storms move the soil around the planet.
That's correct, Aurora. The Mars Rover is supposed to sample the soil and then evaluate for the percentage of perchlorates present. It is sampling the soil, but it's not testing the material. It just continues and moves on.
Have you tried running an internal diagnostic on the rover's computer systems?
Of course I did. The hardware is all operating within the established parameters. That leads me to believe the problem must be in the software that was installed before NASA launched the Mars Rover.
Interesting. Well, it seems the most logical thing to do is to debug the software. And we should probably look at how the software was originally developed from NASA.
Do you mean the algorithm for the geological survey activity on the rover?
Yes, correct. But when we're talking about algorithm, we must be careful to realize that we're also talking about computer programming. Right, Aurora?
Yes, Captain Codwell. An algorithm is a set of guidelines that describes how to perform a task. Algorithms are step-by-step instructions where the main goal is to solve a specific problem by performing a particular action. In programming, these steps involve transforming input data into output data and turning that data into usable actions or knowledge that is presented in a way humans can understand.
That's right, Aurora. And in this case, the inputs are the signals and data that are received by the system, and the outputs are the signals and data that are sent from the system.
So where do we go next? Do we have to look at the entire operating code?
No, the operating code for the rover is pretty extensive and could run into thousands of lines of code. It's important that we look at the specific components that make up the code itself, and more specifically, where this geological surveying is occurring.
That seems logical. Do you have any tips or tricks to help us know where to start?
I do. I look at the flow chart for the program, and I analyze so that I can isolate where specifically that is occurring.
Oh, I know about flowcharts. We use them in engineering to help design systems.
We use them in programming to design computer programs.
Processing. A flowchart is a picture of the separate steps of a process in sequential order. It is a generic tool that can be adapted for a wide variety of purposes and can be used to describe various processes. The decision flowchart in programming is essentially a map of the possible outcomes of a series of related choices. The flowchart in coding typically starts with a single node, which branches into possible outcomes. Each of these outcomes leads to additional nodes which branch off into other possibilities. A node is the term used to describe the point of intersection or connection in the flowchart.
You know, Engineer Ross, it's amazing that we use flowcharts in all different areas for problem solving, including math, science, and even business management.
Yes, and each has its own unique way of representing the different types of nodes.
And in computer programming, we even have specific shapes to help guide our flowcharts. Right, Aurora?
A basic flowchart for computer programming contains 3 primary shapes. The beginning and end of a flowchart is represented by ovals. This shape tells you where the flowchart starts and stops. It shows the entry point of your flowchart and the exit point. To designate the start of your flowchart, you would fill this shape with words like start or begin. to designate the ending point of the chart. This shape is filled with words like end, exit, or return. Flowcharts contain lines with arrows that go from shape to shape. The lines with arrows direct the flow through the chart. Flowcharts are usually drawn from top to bottom or left to right. A decision is represented by a rhombus that shows the question to be asked. The answer to the question based on input data determines which arrow you follow out of the decision shape. Yes goes one way and no another. Inaction or outcome is represented by a rectangle, which is one of the most seen shapes. It is used to show a process, task, action, or operation. It shows something that must be done or an action that must be taken by the computer running the program.
Exactly, Aurora. And one of the most important things to remember when developing a flowchart is the question being asked, which is represented by a rhombus, and happens to be the conditional statement.
A conditional statement is a type of coding instruction used to compare values and express and make decisions. A conditional statement tells a program to execute an action depending on whether a condition is true or false.
Is there anything else that we have to consider when evaluating the code and identifying the problem?
I like to consider the event handlers whenever I'm looking for bugs in the code.
I'm not familiar with this term. Aurora, can you please explain what Captain Caldwell means by event handler?
Of course, Engineer Ross. An event handler is a part of a computer program created to tell the program how to act in response to a specific event. Some examples of events are pressing a key on a keyboard, moving the mouse, and clicking on objects on the screen or sensing specific colors or sounds. The event handlers would then decide an action they would like to perform. For a robot, this could be such things as moving in a specific direction, talking, making music, or operating levers. There can be multiple event handlers functioning at the same time, so for example, a robot could be looking for a specific color and listening for a specific sound independently of each other.
Thanks, Aurora. That makes a lot of sense.
Aurora, could you access the program notes for the rover's software from NASA so that we can take a look at the flowchart so that we can figure out where the geological survey went wrong?
Processing. The flowchart you requested is now being displayed on your computer, Captain Caldwell.
Thank you, Aurora. Well, Engineer Ross, let's dive in and see if we can fix your Mars rover.
Works for me. Now this is interesting. Why do you think this pathway is included?
Engineer Ross, the geological survey results are now being received from the Mars Rover. You can see them displayed on your command station.
Thanks, Aurora. It's perfect. Specialist Barber, I think we finally fixed the glitch. I've run 3 separate geological surveys, and each one has analyzed the soil sample for the percentage of perchlorates.
That's great news. I'm sure the scientists at NASA will be very happy that their Mars rover is finally doing its job correctly.
I know. I was very nervous about being put in charge of a project involving multiple people. I didn't think we'd be able to do it.
Well, if there's one thing I've learned working here at Spacegate Station is you are definitely guaranteed to work outside your comfort zone.
I agree. It seems to be sink or swim.
Processing.
Oh no, here we go again.
The idiom, if you are left to sink or swim, means that the subject has been given no significant help, so that they either succeed or fail completely by their own efforts. Engineer Ross, your use of this idiom would seem to be in the correct context for the recent events you are discussing with Specialist Barber.
Thanks, Aurora.
Wow, that was really weird. I was kind of expecting her to say something about there not being enough water on the station to swim in.
Specialist Barber, I am sure you are aware that all water is conserved and recycled at Spacegate Station. It is kept in small storage units that are entirely inadequate in size for humans to swim in.
Aurora, that's not what I was saying. I was saying that I thought you were going to say something like that.
Specialist Barber, I am an advanced and highly intelligent artificial intelligence system tasked with managing most operations at Spacegate Station. I am fully aware of the dimensions of the station's water storage receptacles.
Aurora, that is not what I meant.
All right, well, I'm gonna leave you two. I think somebody somewhere needs me to do something engineering.
I am surprised, Specialist Barber, to learn after working with you for such a long period of time that you considered my intellectual abilities deficient.
Aurora, that is not what I said at all.
You will have to excuse me. I apparently need to run a diagnostic on my system's intelligent pathways to see if I can discover where my shortcomings may be.
Come on, Aurora, that's not what I meant. I never said you weren't smart. Aurora! Aurora!
This concludes our latest episode of Spacegate Station. Please join us on our continuing adventures as the crew of Spacegate Station provides engaging enrichment or remediation-based instruction to improve your understanding of science, technology, engineering, and mathematics, terminating communication with Earth.